Welcome back, students. Here in this lecture, I am going to demonstrate about two concepts in polymorphism in as well as in inheritance. We called it early binding and late binding. Let us demonstrate first what do you mean by early binding. Here early binding means bind a source code or bind a line of code means a variable name and a function name to a to one or more machine instruction. Whenever we write a simple piece of whenever we write a code, something like this, okay, and when we declare a variable, this is what? This is a name of an identifier. This is a name of a variable. Here, a is a identifier and declared as variable name. Remember, this name a will help a human to remember a name of the variable, but this name need to be bind to an address. When your program execution started in a sequence. That means in top to bottom. Suppose in the main method, if we have more than one instruction, then program execution always started from the main method that we have declared. Thereafter, it executed in a sequence. Means first, the first line going to be executed, then second line, then it follows the continuous source line that you have written in your source code. Then what is the binding here? All this source code will be converted to machine instruction. Then each and every source line will be mapped to a particular machine instruction. It can be one or it can be more. It depends what kind of source code we have written. Now, while a source code is mapping to a machine instruction, we called it sequential address. Sequential addressing. Okay, then what is sequential addressing? See, sequential addressing, the default addressing mode for code is sequential addressing. If we did not change the addressing mode, the default mode will call sequential addressing. When the instruction pointer is a 32-bit register, or in the new computers it can be 64-bit register, contains the address of instruction following the one being currently executed. Means if your code is executing and it started from this line, the instruction pointer register or instruction register will have what? Will have the machine instruction to execute this line. Then due to this binding, this line of source code also going to be converted into machine instruction. This is the reason that whenever we execute a code, this code is executed in a sequence. It is not like that first this line is executed, then third line is executed. Or it cannot start execution from the third line, then it go up. It is not adopted in C and C++ programming. Yes, program execution always be executed from top to bottom. Now, let's assume that we are going to call a function inside this code. Fun A. Now, what is this fun? Fun is a name of a function. And suppose we are going to declare and define this function here. We are writing a very simple piece of code that this fun method going to print the value of the parameter. Okay, so now question is that when this program is executed, how compiler knows from which part of the memory fun is resided, where in which part of the RAM fun is there, and how program control knows this line. When this line is executed, program control needs to be jump here. This process is called binding. I repeat again, question is that how a program control knows which line of instruction needs to be executed. So answer is in the instruction register, instruction register, the machine code will be loaded by the CPU. The machine code will be loaded in which specify the address of any identifier. In this piece of code, fun is an identifier. Fun is the name of function, or we called it an identifier also. So when we compile our code, this name will be converted to a machine instruction and it get binded to its address. It gets binded to its address. Okay, so during function pointer discussion, I have discussed this point in detail. A function is also have an address, specific address. So when this binding process is completed, at the time of compilation, program control easily jump from this line number 18 to the area where this fun method is defined. Once it is jumped into the fun method, it get executed all the line we have written inside the fun method. Once all the execution is done, then program control again jump to the same point from which point it can jump to the function body. So this is the process we called binding, or this is the also process we called a static binding, or we called it static binding or early binding. The reason is that during compilation this binding process get completed, and also compiler knows the exact memory location where to jump. So this process is called early or static binding or compile time polymorphism. We'll see in detail in next example what is compile time polymorphism. This is called early or static binding. Okay, I hope the idea is clear here. I repeat one more time. Program execution always started from the main method. Fine. Then each and every line get executed in a sequence, means one by one. This process is called sequential addressing. So if we repeat one more time, what is sequential addressing? It is a default mode of instruction or addressing for code that we have written for execution. So whenever this addressing mode is followed, so an instruction register, or we also called it instruction pointer, get the address which need to be executed. Okay, which address? Address of an identifier. Here A is declared, so definitely A will have some memory block. Then when we are accessing A to complete this input instruction cin using cin, then what CPU will do? CPU will access this memory block, then CPU will access the memory block of A, and the inputted value will be kept into that memory block. Thereafter, when you are using cout A, again CPU will access the same memory block and the value of A get printed. Thereafter, when we call a method called fun by passing an argument A to that function, then CPU program control register going to be jumped to that function body, from where CPU get knows from the address which is binded during the compilation, from the address. So every line of code going to be executed against the address. Once it jump to that function body, all the line written in the function get executed one by one, and once this execution is over, program control come back to the same point from which it gets to the function body. So this whole process is done during the compilation, and this is the reason we called it early binding or static binding. In next lecture, we are going to discuss about late binding in C++.